Let there be light.
Hello, Engine family. This is Uvi Makiba, CEO and tutor of Engine Pty Ltd. Hello, this is Kivas. I want to know from Engine what is mathematics. Hey, Barker here. In addition, I would love to know why mathematics is important. What is trigonometry and how does it work? By the way, this is Ura.
Hello, Mr. Makiva. I am Bira. My teacher gave us this trick homework. Can you please do it here?
Sorry guys, these questions are too big for me, but then I will try to answer them anyway, according to my own research. Alright, let us start with the question from Kivas. What is mathematics? In an attempt to understand the definition of mathematics, I have tried to read many books, one of which is written by Dr. Amit Goswami, and it defines mathematics as follows.
Mathematics is a meaning given to symbols that represent things, usually physical.
So mathematics must come from the mind.
Getting to your question, Parker, mathematics is important, yes, but then why? Here's what we think. According to Dr. Amit Goswami, there are symbols behind which there is a meaning. It is very hard to differentiate between symbols and meaning. So, in order for us to understand this better, whatever you know now as mathematics is not mathematics. It only symbolizes what mathematics really is. Alright, let us try out a simple example. Mr. Ngwane Silindile, a Lusikisiki born entrepreneur, pays his staff 50 Rand per hour and a separate 200 Rands fixed bonus to keep employees of his company, Sesame. This is a system developed by Mr. Ngwane in order for him to pay his employees. So, mathematics in its real sense is a system developed by God to run the whole universe. As for Mr. Ngwane's system, we can assign symbols in order to demonstrate it, just as we can assign symbols to demonstrate the laws of nature. In the next 3 classes, the company will explain the difference between these two pictures, for they portray a very good example of why mathematics is important. Now to the question Ura asked, what is trigonometry and how does it work? It is hard to tell, but we will answer this question by first consulting a dictionary and work it from there to what you now see in papers termed as mathematics. My dictionary here defines trigonometry as the mathematics of triangles and trigonometric functions. Once you get grasp of triangles and trigonometric functions, then you will only be required to represent that knowledge on a graph. Then that will be all for trigonometry. In our next class, we will use 4 triangles that you will need for this year. First of all, we have equilateral triangle, then a right angled triangle, then we have a scalene triangle, and lastly we have an isosceles triangle. The most basic trigonometric functions in mathematics are sine, cos, and tan, but we shall explore them in more detail in the next classes. On your right there, I have shown you their original functions. Any graph other than these ones are simply derived from these original graphs. Now let us have a look to the homework assignment given to Bira so that we may be able to try it here. So let's begin. If cos 61 degrees is equal to k, determine the following without the use of a calculator in terms of k. In 1.1 we have sine 119 degrees. Then in 1.2 we have tan 29 degrees. Activity 2 requires us to simplify the following expression to one trigonometric ratio of p. The expression reads as follows. Sine 360 minus p plus cos 270 degrees all divided by sine 90 minus p plus tan 180 plus p plus tan 360 minus p. So if cos 61 degrees is equal to k, then it means cos 61 degrees is equal to k over 1. We do that so that we may be able to know which one is an adjacent and then which one is hypotenuse. So we already know that our adjacent side is k and then our hypotenuse is 1. So what about our opposite side? We need to find our opposite side using Pythagoras theorem. Why? Because we have a right angled triangle. Whenever you see a right angled triangle, think of two things: trigonometric ratios and Pythagoras theorem. Pythagoras theorem states that hypotenuse squared is equal to side squared plus side squared. In our case, r squared is equal to x squared plus y squared, where r represents our hypotenuse, x represents our adjacent side, and y represents our opposite side. So when we work out the value of y, we get two possible answers, plus or minus root 1 minus k squared. So we shall choose the positive answer because 61 degrees is in the first quadrant and all values of y are positive in the first quadrant. Now that we have figured out all the sides of this triangle, I think we may now be able to try 1.1 and 1.2. In 1.1 we have sine 119 degrees. So you are already questioning yourself, how can we change 119 degrees to 61 degrees? Alright, so 119 degrees is the difference between 180 and 61 degrees. You can even try it in your calculator. 180 minus 61 degrees is equal to 119 degrees. So instead of putting sine 119 degrees, you can just say sine 180 minus 61 degrees. Then sine 180 degrees minus 61 degrees is the same as positive sine 61 degrees. Why? Because 180 degrees minus 61 degrees, which is 119 degrees, is on the second quadrant, and sine is positive on the second quadrant. Therefore, our final answer will be root 1 minus k squared all divided by 1, which is equal to opposite over hypotenuse. Alright, let us move to 1.2. In 1.2 we have tan 29 degrees. Once again, your goal here is to make sure that you change 29 degrees to 61 degrees. How do we do that? So 29 degrees is the same as 90 degrees minus 61 degrees, which is in the first quadrant. As I will prove to you in the next class, tan 90 degrees minus 61 degrees is the same as cot 61 degrees. Cot 61 degrees, on the other hand, is the same as 1 over tan 61 degrees. Then, if you take the denominator, tan 61 degrees is the same as root 1 minus k squared all over k. Then because we had 1 over tan 61 degrees, we will then change all of this. The numerator will become the denominator and the denominator will become the numerator. Hence our final answer will be k all over root 1 minus k squared. Alright, let us now see how do we answer activity 2. Alright, so activity 2 requires us to simplify the following expression to one trigonometric ratio of p. Before you even attempt this question, you need to keep in mind the diagram on your right. It is called the cast diagram, which means in your first quadrant, all trigonometric ratios are positive. In your second quadrant, only sine is positive. In your third quadrant, only tan is positive. Then, in your fourth quadrant, only cos is positive. So, in our diagram, we have theta, whereas in our question, we have angle P. So, it doesn't make any difference as long as you will understand that P is represented by theta in the diagram. So, having said that, we now know that sine 360 degrees minus P is on the fourth quadrant, and sine is not positive in the fourth quadrant. Therefore, we have negative sine P. Cos 270 degrees is the same as 0. Then moving to our denominator, sine 90 minus P is the same as cos P. How is that possible? First of all, you will ask yourself sine of sine in the first quadrant, which is 90 degrees minus P. Then you know that sine is positive in the first quadrant. Then whenever you have 90 degrees plus or minus, or 270 plus or minus, you change sine to cos or cos to sine. So for example, if we had sine 270 minus P, we would change sine to cos, you see. Then tan 180 degrees plus P is the same as positive tan P. Why? Because 180 degrees plus P is on the third quadrant and the tan is positive in the third quadrant. So we have tan P. Then as for tan 360 degrees minus P, we know that 360 degrees minus P is on the fourth quadrant and the tan is negative in that quadrant. Therefore, we will have negative tan P. Then positive tan P and negative tan P will cancel each other, and then we will only be left with negative sine P over cos P, which is the same as negative tan P. Alright guys, let us stop here for now. We will continue next week.